afternoon, everyone. I think Professor Liu assigned me to conclude the symposium, so she arranged me the last one. It's a joke. I hope the last, but not the least, hopefully. Because the topic where I'm going to discuss is different from the previous, because the data we collect is not from the satellite or some device, it's from the fishery activity. We observe the Earth system by humans' activity. So okay, this is my co-author, President Lee and Dean Lee. So my team is a big one. Okay, this is from the 1980s, the global ocean warming, the speed is getting speeder. You see that there's a 26 hotspot area, and in this area, the sea surface temperature is on the top 10 with the speed of the rising trends on top 10%. So most of them are in the boreal area or in the boundary of the ocean. There are several studies to observe the biosphere's reaction to such a warming. As you can see that in Alaska, there are so many fish that migrate to more northern area. And in the southern hemisphere also, there's some study from there's an observation on Tasmania. There are many new established species from the northern area to more southern area. And there are so many cases, I just pick up a few of them. And in the UK, like the haddock, they move more northern side than before in the recent 20 years or So such a phenomenon is like a matter of course because the fish expand to higher latitude, and not only latitudinal difference, but also some fish the habitat is going to deeper ocean, because of the warming of the ocean. So this is like a global phenomenon. How is the phenomenon in Taiwan? This is what we concern. So we have a long observation from early 1980s. This presentation is a collection of all the information to show you what's going on in this area from the fishery data. I would like to give my talk in four parts. The first one is how's the physical element. This is some feature of this area. So you can see the sea surface temperature. The rising trend is very significant. This is average situation of the surrounding area. If we look at the different area, you can see no matter in the northeast or southeast or eastern region, during the past 30 years, the temperature rising trend is very significant. Average amplitude is about 0.7. And behind such a rising temperature, actually, it's because of the current system. There's a change in current system, and we can observe this by the sea surface temperature from use statistical the figures. And in here, the blue one is the ocean temperature that is lower than -1 deviation, and the red one is positive, is higher than one deviation. All the others is normal year. In the past, you can see temperature. This is the spatial distribution. This is a temporal distribution. You can see the ocean temperature getting higher and higher. And the area with negative anomalies is getting less and less. And we can see, no matter in winter or in summer, there's a very strong indication that the trend is a trend of diminishing of China coastal current and enhancement of a crucial current. This is the phenomena behind the sea surface temperature. And not only this, another feature is the extremes. I think this morning Professor Liu have given the typhoons, the super heavy precipitation brought by typhoon. The number of typhoon, total number, is not increased very significant, but the most, the strongest typhoon with a heavy precipitation took place in the last 10 years. But in wintertime, the cold extreme may also induced because of the temperature differences between land and the ocean in wintertime. The differences is larger, is higher than before. That it was explained by some expert. It's not by me. Because of this, so in wintertime, some cold extreme occur. The most famous one is in 2008. There's extreme cold. We call it exceptional intrusion of China current, coastal current. And in that year, in the island, Tunggu Island, normally, even in wintertime, the season temperature is above 20 degrees. But in 2008, about 3 weeks, the temperature dropped very low, so it's caused a disaster of the ocean ecology. Yeah, and 2010 also a smaller one. So not only typhoon, but also in wintertime, the cold stream also occur more frequent than before. Now second, what's the impact from this kind of climate change on fishery resources? Of course, the extreme would cause mass mortality and some escape recruitment of fish. But how is in long run? In the long run or in long term, the distribution and the total abundance and also the fish activity may be changed. So we are going to give you the detail of what we found in the recent year. Of course, extreme would cause mass mortality. This is in 2008. Many fish die, and the economic loss is about $1 billion NT. So this is the extremes, damage from the extremes. And typhoon, yeah, some say typhoon is maybe cause damage from fish, human society, but maybe good for the fish community because they enrich the ocean, they pump up the nutrient. But the previous one, Dr. Barrier said it would cause the toxin of the ocean. That it may be another disadvantage. It's a negative influence. But in Taiwan, yeah, the typhoons, the influence, because in the southern area, there's an agriculture area. So every time when the typhoon causes some flood and many of the fish agriculture, they would escape to wide. So every time, this is the catch of this fishing village. That every time the typhoon occur, and this is the catch that more these agriculture fish were caught. So this is a short-term benefit to fishermen. but actually it is not good for the ecology because these guys eat many food. So this is okay. Now what is long-term influence from the climate change? Now we give you information. This is we call it malate. This is very important endemic species in Taiwan. And before 1980s, these fish would migrate to the southern Taiwan. It's in the winter near the coldest week every year. But in the end of the century 20, the end of the 1990s, they not go to the south anymore. And we will give you the more recent data. Yeah, from the 1990s, their better fishing ground is in the northern Taiwan, and in the southern part is fewer and fewer. Yeah, so this fish is come with the cold water mass. When it's not going to the south, the stock go to the south is less and less, and the fishery target on these fish cannot survive because they have to target on the intensive schooling fish school. So now once this kind of fishing bowl once been the largest fishery in the western area, but now it's fed out. It's history. Now it's replaced by the small-scale gillnet to catch the dispersed fishes school. And fortunately, this agriculture is replaced by the capture fishery. And there's another case. We have collected this kind of species composition data from the fishery for a long period. In Taiwan has two family of anchovy. One is the in grasses. This is come with cold water, and another is in grasses clylona. This is they prefer warm water, and Taiwan is located in the southern extent of this species, or northern extent of this species. Yeah, if we look at the catch composition, you will find in spring season the cold water species is decline. This is, and also in autumn season is dominated by the warm water species, and almost the cold water species almost disappeared in recent years. So in the very low level of the food primary in the ocean, there is change. There is we call it the regime shift of anchovy fish society. Yeah, and even in a very short period of a summer season, there are two major species caught by torchlight net fishery. If we look at the past 15 years, the fish come with warm water is bullet tuna. It's getting more and more, and the fish come with the counter crucial current from the northern side. It's getting fewer and fewer. And these two species like environmental competitor. So this is also indicates warm water species replace cold water species. Yeah, we're still going to keep observe on these fishes. So is there structural change can indicate what's going on in the fish society? Maybe the SandNet catch data can answer the question. SandNet data is a passive gear. So just set on coastal area. We have about 60 set of SendNet. So we collect the catch composition data so we can see what's going on. This is the result. And you can see the species number getting more and more, and diversity higher and higher. And this data is collected from this area. That is because the intrusion of a coastal China current is the chance is less and less. The fish come from northern side species is simple, a few species. So when the chance of intrusion of cold water get less and less, so the diversity get higher and higher. Yeah, what's the future impact? We can observe on the seasonality change. This is a trend of 49 seasonal migratory species. Summer is not a major fishing season. Spring and winter is major fishing season. Before, the catch of these migratory species is concentrated in winter and spring, but now it's not anymore. Okay? Look at this year, it's almost equal. Seasonality is changed. So it may be hint that the Taiwan Ocean environment is more like a tropical one, probably. And this is another analysis. We can see this area is a key area. When this temperature of this area getting lower with the brim or broad abundant of fish migrates from south. So that's why the winter and the spring the abundance getting less and less. That's because this area the temperature getting higher and higher, and we can estimate by a very simple way. We use the IPCC scenario data. I think this is the average the temperature estimated in this period. This temperature is almost about highest is about 2 degrees. So if we use the single regression model, we can find most of the fish will be decreased, especially for those species migrate with China currency. Only one water species will partially increase. When we estimate the situation in 2055 and about 5 to 50% reduction in catch. Another similar simulations by the Chong 2009, the bigger area. So you can see almost a big portion of the area is decreased in catch. That is because the increase of ocean would decrease the productivity. So this is a big change in ocean, and fish, the adaptation of fish is they could adapt very quickly. But are we ready for the adaptation to climate change? Because traditionally we only use these tools to control. We control based on the investment, we control the process, we control the total output. But this is not enough, because the climate trend maybe would cause in a very destructive development. Maybe half of the fish, the catch with a decrease, 50%. That means many fishermen would lose their livelihood. So this is a big problem. So we need many external tools. This would not a nature scientist can solve. We need more social scientists. We need more political tools. So let's just a very big problem for the fishery management. So I think I have to conclude my talk. This is my conclusion. I think I don't want to repeat this. And the last one, the traditional fishery management measure will not be able to adapt the problem caused by climate change. So more external precautionary or adaptive measures need to be introduced to reduce the impact and risk. Okay, thank you for your attention.
Thank you. 2 questions.
Have you correlated the ENSO event El Nino La Nina with our fishery statistics?
Yeah, yes, we have. But today I only discuss about the long-term change. But during the long-term change, El Nino La Nina may occur. Yeah, the interannual influence is also very important. Very important. Yeah.
Have you evidence of this correlation to show?
Oh yes, we have. We have.
I'd like to know.
Okay. There's so many items, so maybe I can give you one. For example, that is in La Nina period. La Nina period, that would be the crucial current would be enhanced. Yeah, and fish come with the crucial current will become more and more. Yeah, for example, in wintertime, the eel, the eel and some fish travel with the crucial will become more.
And how
Yeah.
about
El Nino.
El Nino?
Yeah. The El Nino is opposite.
Opposite.
It's opposite. Yeah. Yes.
So correct, and so with the crucial current and the catch of the fish.
Yeah. Very, very highly correlated for many species. Many species. We have some report. Maybe I can give you after the meeting. Yes.
Any questions? Thank you, Professor Liu. So Professor Liu's presentation is the last.